Hello friends, in this session of mensuration, we'll be covering conversion of solids from one form to another. Now what do we mean by conversion of solid? It implies that we change the solid to some other shape. Say we change a metallic cylinder and to a sphere. Now it could also mean merging two or more solids to convert into one solid of same or different shape. So say for example we have two small spherical balls. Now we merge them together and we create another bigger spherical ball or maybe a metallic cylinder. Now this conversion requires the material to be remolded. So what we're trying to say is that we take the material of the existing solid or multiple solids as the case may be, and we'll remold it to another solid of the desired shape. Now this would require the volume of the original object is equal to the volume of the final object, because we have the, supposing we have an iron ball. Now small ball, we mold it, we heat it and we mold it into a cylinder now. So that would mean the material that we had for the sphere, for that ball, remains the same when we change it to the cylinder. Now let's understand conversion of solid through examples only. How many spherical balls of radius 2 centimeter can be made out of a cube of side 44 centimeter? So what would that mean? Now we have one cube of side 44 centimeter, which is 44 by 44 by 44 cube we have. Now we need to convert it into spherical ball of radius 2 centimeter. So how many such balls can we make? Of course it'll be more than one. So now let's see how many of those can be formed. Now let's assume we get n number of balls. Now radius of the sphere is given to be 2 centimeters. So volume of the sphere we know is given by the formula 4 by 3 pi r cube, which would become 4 by 3 pi into 2 cube, which comes out to be 32 by 3 pi. So volume of n balls would be 32 by 3 pi into n. Now let's find out the volume of the cube, which is 44 cube. Now equating the 1 and 2, because as we said that if we are converting the solid, the volume of the original solid remains the same as the volume of the new solid that we've made out of it. So that would mean 32 by 3 pi n will be equal to 44 cube. Now this gives us, on solving this, we get n is equal to 2541 balls. So this is the number of balls that we can form. So friends, let's look at another example for the conversion of solid. A well is dug with internal diameter 10 meter and the depth of the well is 14 meter. The earth taken out of it is spread around it to make an embankment of 5 meter width. We need to find out the height of the embankment. So what does this mean? This well is being dug, which is of radius r2. We are taking it to be r2. And now whatever earth is coming out of it, that is spread here in this yellow region as an embankment of width 5 meters. So we are taking the radius of this outer circle to be r1, which is necessarily r2 plus 5. Now we know that the earth which has been dug out from the well will be spread as an embankment, right? So what it necessarily means is the volume of that would be equal to the volume of this area, volume of the earth which has been spread out in this area. So let's find out how much of earth has been dug out from the well. It is equal to pi r square h. So now this is R2. So pi R2 square h, because this is R2. And R2 is 5 because the diameter is 10. So we are saying the radius becomes 5. So this radius is 5. And this radius becomes 5 plus 5, which is 10 meter. So it is pi r square h with r2 square h, which would mean 22 by 7 into 5 square into 14 is the depth of the well. And this comes out to be 1100 meter cube of earth has been dug out. Now area of the embankment is equal to pi into r1 square minus r2 square, right? So that will be this is how we'll find out the area of this yellow region. Pi into r1 square, which is the area of this external circle, minus pi r2 square, which is the area of the internal circle. So this becomes the area of the embankment, and this comes out to be 22 by 7 into 10 square. R1 is 10 minus 5 square, and this is 1650 by 7 meter square. Now height of the embankment will be equal to the earth dug out from the well divided by this area of the embankment. Why? Because we are saying the volume of earth dug is equal to the volume of the embankment, which is height into the area. So we get height of the embankment equal to earth dug, which is 1100 meter cube, divide by 1650 by 7, and this comes out to be 4.66 meter. So that will be the height of the embankment. So friends, now let's look at another question. Water in a canal which is 1.5 meter wide and 6 meter deep is flowing at the rate of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is required? So we are saying this is the canal which is flowing, and this width is 1.5 meter and its depth is given to be 6 meter, and the rate at which the water is flowing in this is 10 km per hour, which can be said to be 10,000 meter per hour. So we'll first find out the volume of water that flows out in 1 hour. This will be equal to 1.5 into 6 into 10,000, which comes out to be 90,000 meter cube. Volume of water flowing in 30 minutes will be half of that, which is 45,000 meter cube. And now this much of water will be equal to the volume of water in the area which is irrigated, which would mean the area which is irrigated multiplied by the height of water, which is 8 centimeter or 0.08 meter. So volume of water flowing will be equal to area multiplied by 0.08. So to get the area, we can say this will be equal to volume of water flowing, which is 45,000 divided by 0.08, and this is 562500 meters square of area will be irrigated with this canal, which is 1.5 meter wide, 6 meter deep, and water flowing at 10 km per hour.
Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.